Okay, as we said, tangent is a line, segment, something that intersects a circle at one and only one point. That right there is that point. That point is called the point of tangency. And that's where what? How could I say that? Where the tangent intersects the circle. Makes enough sense there, doesn't it? Everybody okay with that? Okay. These are all called something. These are all called common tangents. Why do you think these are common tangents? Oops, wrong two. Tangent, that is tangent to two or more circles. This one is a common tangent because it's tangent there and what? Right there. You can have common tangents like this, right? This is tangent here and tangent what? On this circle there. You can have one like this, where they just perfectly meet right there. A line and the circles intersect right there. I'm sure there's other ways you could draw it. You could have three of them to where, you know, it intersects three circles, but it's called a common tangent when that happens. Any questions about that? Hmm? Can I move on? No, I cannot. What?
Okay, you can move on.
Not yet.
Yes, ma'am.
Sorry, I'm really slow at writing.
It's okay. We'll forgive you.
Okay, I'm done.
All right. We're going to talk about this now. Isn't that pretty? Free-handed. Just anyway, we're going to call this important fact number 1. Usually we call these what? Definitions, theorems, postulates, axioms. We're just going to change it up there. We're going to say, just hey, this is an important fact here. In other words, you're probably going to do some problems to deal with this. A segment that extends from the center of, or the center, I'm just going to say center. We know we're talking about center of circle, don't we? Do I need to write anything else? From the center to the point of tangency is always perpendicular to that tangent. So what am I saying here? I'm basically, am I not in essence saying connect the dots? Start where? At the center of the circle and go to the what? Point of tangency, just like that. What should happen? What should it happen? It should be what? Perpendicular to what? The tangent line, correct? Is that not what it's saying? What does perpendicular mean? Creates a 90-degree angle. But it shouldn't matter from any center. From the center to any point of tangency. There's only one center, shouldn't say any center. So what about this tangent over here? What should happen? Does it seem as if it does? Okay. What about this tangent over here? Does it seem like it does? Well, that one doesn't look as good, does it? Just means I didn't do as good a job of drawing it. What about this one right here? For the most part, seems to look like it holds true, doesn't it? What do all those angles seem to be? 90 degrees. Now, here's the deal. When you do your homework, or when they have some of these drawn, they're probably going to be drawn just like that. What have they left off? Right. They want you to know, not because it looks like it, but because of the theorem, or important fact number 1, that any time a line segment, anything goes from the center to the point of tangency, it creates a right angle. Hey, and sometimes in life dreams do come true. And today's proof of that. We're almost 5 sections away from chapter 8, and look what you get to deal with even more. When I connect the dots there, what are all these little things I'm creating now called?
Triangles.
But more specifically,
Oh, right, triangles.
I told you dreams come true. So what are you guys going to get to have fun doing again? Pythagorean's theorem, sine, cosine, and tangent, special right triangles maybe, if you're lucky. Isn't that awesome? Like I said, this is proof that your dreams do come true. Next time someone says it doesn't, you tell them about this day. Oh, nah. So, exactly. He doesn't know what he's talking about. Exactly. You don't have to do 1 through 4. You don't have to do anything. He's going to do 1 through 4. We'll see how his grade in this section turns out. Now, he must have heard that from some internet guy. Now, so this is important fact number 1. Is everybody okay with this important fact? So when you see something going from the center to the point of tangency, you know it's going to create a, come on, say it.
Right
Okay, I'm glad one of you. Again, when it goes from the center to the point of tangency, it's going to create a much better. And then if you connect it to there, you know, you'll have some right triangles to play with. Okay? If it was December, I'd take a picture of this and put it on, and have your parents put it on a tree for Christmas. Okay? That was going a little far, wasn't it? Okay. All right, important fact number 2 will look like this. How did I know you were going to be the one that saw an ice cream cone out of that? Important fact number 2. And I call it important fact number 2. Important fact number 2. Now, when 2 tangent, now I want to say segments here. So when 2 tangent segments to the same circle come from the same point, the segments are, what does this little sign mean? Right. So as Braden was saying, when your tangents create an ice cream cone, what do you know about the sides of the ice cream cone? Isn't this the side of the ice cream cone here and the side of the ice cream cone here? What am I saying? That the sides are the same. And that kind of makes sense because isn't a circle just this perfectly, I mean, circle is just one of the perfect things. It's perfectly the same distance all the way around. So if you pick a point and you go to one side and go to the other, it would make sense that because it would perfectly go to each one, right? The same distance. And someone asked the questions, well, why at last hour? Well, look, if I made kind of an ellipse like this, okay? And I did the same thing. Because this isn't perfect, these aren't the same, are they? Because it's not, you know, symmetric all the way around, because it's crooked. You see how this segment is now longer than this one? But however, when you have it coming to what? A perfect circle at the point of tangency, they will be equal. Guys, and I expect you to show you're working all this stuff, but just for, you know, all intents and purposes, as far as test taking, EOI test taking, ACT test taking, the nice thing about that is they're going to draw a circle. A circle's always going to be in proportion, I guess is what I'm saying. They're always going to draw it perfectly, right? So when you run into a bind on a test or something and you can't remember exactly the theorem, you can somewhat go by how it looks. Not necessarily maybe the measure of the angle, because they can mess with that. But, I mean, doesn't it look like these two are what? Congruent? Would you guys agree? Well, part of it is I used a template and drew a perfect circle. Actually, I just did it freehand, right? But you see the point I'm making? And on all your tests and stuff, your standardized tests, your ACT tests, because, guys, you're not going to, unless you're just extremely gifted, you know, or have an eidetic memory, you're not going to remember every little fact. But the one nice thing about circles is, you know, most of the time they're not going to draw their circle on an ACT test like that, trust me. Okay? It's going to be a circle. So the things that look like they happen probably do. I mean, do those not look like right angles? Now, that goes against kind of what I teach, but in a test taking, you know, looking to the future, you know, maybe you'll remember that, you know, hey, circles are, you know, if they draw the circle perfectly, you can use that to your advantage in a multiple choice test. Hey, and one thing we are trying to teach you is problem solving skills. Aren't you solving a problem there? Problem you don't know the answer and trying to find it? Okay, that's part of what really geometry is kind of teaching you as well, is analytical thinking, problem solving. Okay, enough about other things. Let's give an example. Look at this sucker right here. Which important fact does this deal with? Can you guys tell me? What important fact? You got a 50-50 chance. I said, what important fact?
Number one.
Don't guess. Okay. We'll review. Here's the picture that goes with important fact number 2. Here's the picture that goes with important fact number 1. Which one does it look more like? 2. Because you've got 2 tangents coming from what? The same point, right? 2 tangents coming from the same point. I've just got 3 of them in one circle, don't I? So let's say I made this 13. Made this 5, made this 4. What is the perimeter of that triangle? How am I going to do that, guys?
Isn't it 2 times the length?
Nope. Perimeter is the distance all the way around, walking all the way around it. Let's find the things we can up here. What do I know about right here? If this is 5, what's this?
5.
Because of this says that if they're 2 tangents coming from the same point, where's my picture? Covered it up. They have to be congruent, right? Isn't this the same thing right there? Just the point's a little closer to the circle? Would you agree? Okay, so if that's 5, that's 5. How does that help me?
Helps find the other angle.
Helps find the other one, because what am I saying here? That this whole thing is what?
13,
So if that's 5, what's left for this to be?
8.
Now, this is 2 tangents coming from the same point, so these are what? Congruent, correct? So if this is 8, what's this? Almost all the way around. Over here, this doesn't tell me anything about this, though. But does this?
Yes.
Isn't it equal to this? So if this is 4, what's this?
4.
And then this is the other thing. This is, like I said, on measurements, I didn't do this to scale at all, did I? But according to what's in front of me, this is correct. So what is the perimeter? I would simply go 8 plus 8 plus, started here, 8 plus 8 plus 4 plus 4 plus 5 plus 5. That would be everywhere, wouldn't it? What do you get? Huh?
34.
34? Okay. Not too terrible, is it? I think we can do that. Now, let's get out our handy dandy red books. And let's start with number 1 on page 131. Your directions here are to determine whether each segment is tangent, to the given circle. Justify your answer. Well, I tell you what, as someone grading homework assignments, the justify is more important than the answer. I do realize that you have the ability to write the word yes or the word no and guess. What I really want to see is the what?
Work.
What answer am I worried about? The yes or the no or the justify your answer? Justifying your answer. Sometimes I don't get it. I mean, as a teacher, well, yes, I do. It's you guys want to guess, but you don't want to justify your answer. You might as well not have done this problem. Justify your answer. Now, how are you going to justify your answer? Well, let me know how you got it. Why can you say that? Because right here, do you guys think this is a right triangle? Do you think this is a tangent line?
Yeah, it looks like it, yeah.
It looks like it, but we can't just go by that. So what could be my test? Well, what do I know? Important fact 1 or important fact 2? Are we dealing with it? The first one, right? What does it state? That any segment that goes from the center to the point of tangency has to be what? Perpendicular, meaning it creates a, which in mean this would be what type of triangle? How can I test to see if something's a right triangle? You said it, Ashley, a second ago.
Pythagorean theorem.
So what I need to see is where's my hypotenuse?
41.
I need to see if 41 squared is equal to, and I'm going to put question mark, what are the sum of the square of my other two legs? My other two legs? 9 squared plus what?
40 squared.
What is 41 squared? Okay, now, let's see what this is over. 9 squared is 81 plus what's 40 squared? 1600. What do I get over here? 1681. So what sign should I put in between there?
Equal.
They are equal. So is this a right triangle?
Yeah.
So is this a tangent? Yes, it is a tangent. Now, do I need to write some long explanation out? Tell me if I do.
No.
No,
How did I justify it?
by working it out.
By showing that it fit into the what? Into Pythagoras' theorem. That's my justification right there. Your justification doesn't always have to be words. Questions? Over this one. Well, is this situation really any different? So in order for me to see whether that's a tangent, I have to see if this is a what? Right angle. And how I can tell that is to see if all of this fits into what? Pythagorean's theorem. What's my hypotenuse?
13.
No, it is 13. It is always the larger of the three.
Oh.
So, is 13 squared the same as 4 squared plus 12 squared? What is 13 squared? 169. 4 squared is 16. 12 squared is 144. So you get 160. Are those equal or are they not equal?
Not equal.
No.
Not equal to. So I have now justified that. No, that is not a tangent. Not so terrible, is it? Now, moving on, I'll zoom out and let you guys copy this all down. I'd rather you just watch. Let's look at this one right here. It says find x. Assume that the segments you see are tangents. Round in there is 10th if necessary. Which important fact is this dealing with?
2.
Number 2, which states that anytime you have tangents coming from the same point to the same circle, what do we know about those segments created? They are equal. That distance is the same. Well, hey, does that help me make an equation with this algebra-looking problem?
Yes.
What is my equation?
30x minus 6 equals x plus 10.
Any questions there? I'm going to do kind of the faster way of solving it so we can get done a little easier. Does everybody see that I'm just doing, you get 2x is equal to 16. X is equal to 8. Is that what they asked for? Yep, they asked for 8. X, didn't they? Now, everybody see how to do that? Make sense? Is this any different? Except they flip the ice cream cone over? You have 4x plus 2 is equal to 2x plus 8, right? All right, let's go to 5. Is this any different?
Yes.
Looks different to me. Is the coming from the same point going to two tangents? No, one of them's going to the center. What does this seem to look like? Important fact number 1 or important fact number 2?
Number 1.
Important fact number 1, which states that segments coming from what? The center to the point of tangency must be right. Create a right angle, correct? How does that help me? How does that help me find x? Oh, somebody. How does that help me find x?
You do the Pythagorean theorem.
Because this is a right angle, I now know that I can use Pythagorean's theorem, which states that the hypotenuse, which is, pointing at it, 17 squared, is equal to the square of the sums of the legs, which would be what? 8 squared plus what? X squared. Questions? What is 17 squared? 289 is equal to, what's 8 squared? No one knows what 8 squared is.
64.
Plus x squared. Subtract 64 from both sides. I'm left with 225 is equal to x squared. Now I don't want to know what x squared is equal to. I want to know what x is equal to. So how do I make an x squared into an x? I take the square root of it. But I have to always keep an equation balanced, so I take square root of the right. I have to take square root of left. What's the square root of 225? 15. That one comes out nice and even. And because they told you to round to the nearest tenth if necessary, if it does come out to be a decimal, you can now make it a decimal, can't you? Your question did not tell it to be exact, or by saying round, it's telling you it's okay to use decimals. Is this one here really any different? No, not at all. Except for x is now the hypotenuse. Now let's go to number 7. It says find x and then find the perimeter. Which important fact am I probably going to use here?
Number 3.
There was no number 3.
Well.
It's like the
number
third
2.
picture, yeah, which says that when they come from the same point, they're what? So if this is 4, what's this? This is 13, what's this? If this is 9 and this is 2x, then 9 has to equal what? 2x, does it not? What's x equal to?
4.5.
So we found x, but they also want us to find the perimeter. So this is also 9, is it not? So to find the perimeter, I just go 9 plus what? 9 plus 4 plus 4 plus 13 plus 13. What do you find the perimeter to be? Anybody?
Working on it. 52.
Is this any different?
No.
It just has how many? 4. It's a 4-sided now. So that's 13. This is 5. This is 5. This is x, but x is actually equal to what? 13, because this is 13. This is 5, because this is 5. You can find everything, can't you? Stuff isn't so bad, is it? I mean, like I said, dreams do come true. Your assignment is numbers 2 through 6, 9 through 22. We got plenty of time. Write problems, draw figures, show all steps and work. Hey, don't get mad at me. That's what Canvas said to do. That's what we got to do.
Can't do that, not you.
No, I don't think that's true. Where's my little freeze button?